Hi there, this is the new lecture starting from the Arduino. So from today onwards, I'm going to teach you the Arduino interface. So Arduino is a high-level language, and it has several microcontroller boards available. So the today's discussion is about Arduino Uno, which is the most widely used and most economical version of the Arduino, so which is more famous. So this lecture covers the basic functionality of the Arduino Uno board and how this pins and the purposes of these pins and different boards of the Arduino Uno board. So Arduino interface. So this, apart from that, we have a software interface called Arduino IDE. So you need to download it from the web. Then you, once you install that, you can interface this board to your computer, and you can program this board using the Arduino IDE. You can write codes and you can work on projects, and so quite interesting projects can be done using the Arduino boards. There are different types of Arduino boards, even using this Atmega 328. So there is Arduino Nano board and Arduino Mega, and there are different types of boards available for different purposes. But this lecture only covers the Arduino Uno, which is the most widely used and economical version of the Arduino. So, like I mentioned, this Arduino board has a microcontroller, which is the AVR microchip Atmega 328P through hole type. That's why this board takes more space. And so, before we move into the board, I would like to explain the functionality of the Atmega 328P. So, this is nothing new for you, because if you look at this datasheet of the Atmega 328P, everything is in here. But for this lecture, so it is good to brush out what you have already known. So it has a VCC pin for digital inputs and ground. For analog inputs also, it has a AVCC ground and analog reference. And there are some digital pins and analog pins, and this is analog pins available, but you can also use them as digital. So this is a reset pin. If you pull it down to the ground, the microcontroller will be reset. So these pins can be used as pin change interrupts, but there are some hardware dedicated interrupts used for different two pins, that is PD2 and PD3, IN20 and IN21 for external interrupts. And so basically, we have port C, port B, and port D available for your any kind of general purpose inputs and outputs. Port C is dedicated for analog inputs. We have 6 analog inputs. It's starting from A0 to A5. You can select any of these. All right. Now, if you look at this, the functionality, pin number 2 and pin number 3 is used for serial communication. It is a communication protocol. This is the serial data receive, and this is the serial data transmit. And INT0 and INT1 is for pin change interrupts, external interrupts. So there's a hardware associated for that. And this is a clock for the microcontroller, and it can be also used as timer counter, external counter input for your timer counter 0. And this is the crystal oscillator. If you use an external oscillator to run your microcontroller for fast operation and accuracy, you can couple it to here. And at Arduino Uno board, it has a 16 megahertz external oscillator. So far, we have been using the internal 8 megahertz oscillator, but Arduino has external crystal oscillator for more accuracy and high speed. And T1 here is the timer counter 1 external counter inputs. So if you send any pulses, it can take the account them. And AIN0 AIN0 and AIN1 for the analog comparator. This one is for 0 for negative input. 0 for positive and 1 for negative. This one is a positive input and the one is for negative input. And clock out is to, if you want to output the system clock, you can use this pin. Sometimes you need to calibrate your clock and see if there are any changes, so you can directly copy the system clock running inside to this pin. So using external oscilloscope, you can monitor what is the clock speed and you can observe any deviations. ICP1 is the timer counter 1 input capture input. And these are used for timers and counters. And we have several pins in the Arduino used for PWM signals. This is for pulse width modulation. You can have a variable duty ratio, which is quite useful for motor drivers, voltage regulators. And this pin, there are 6 PWM outputs. And also we have communication protocols. Like I mentioned, we have this serial communication, which is known as ISAT or RS-232. And this is the 2 pins for I2C or 2-wire interface communication. This is the clock 2-wire serial bus clock line. And this is the data line. And we also have the interface for SPI communication. So it has SPI bus master clock. This is the slave input. This is the output slave input, and this is slave out. And so this is the master and save select. So you need to have 4 pins to communicate with SPI. So we will discuss more about this communication protocols later. And so this is a functionality of ATmega 328P, which is very much familiar to you. And this chip is embedded to this Arduino Uno board. This is how it looks like. First of all, you need to power up the board. You can use the USB jack. This is type B USB jack, which is got if you familiar with the old type printers, you can easily find this kind of USB cable, but you can buy that with the board. So once you couple it to the computer using this USB cable, the board is powered up. You don't need external power. Once the programming is done, if you still want to use this for projects, you can you can plug external power source when you don't have the USB power. So this is the power jack. So the outer layer is for ground and inside is for supply. So the power jack, you can use a power pack and power pack adapter and plug into here. So the voltage should be range with this 7 to 12 volts. 7 volts is the minimum and 12 volts is the maximum. And it also has a reverse polarity protection functionality. If you set this, it won't damage where there's a diode. So you need to have the correct connection if you want to power the board. So that's the power. And so once you give the power to the board, either using USB or power jack, and also you can power externally if you have a battery source or anything. You can plug that positive supply to here and ground supply to here. Then also you can power up the board. So 3 ways of powering up: USB jack, power jack, and external in supply. Make sure that is also in between 7 to 12 volts, otherwise it will damage your board. So once you have the power on your board, it has an internal voltage regulator, linear regulator, so it can step down whatever the available voltage to 5 volts when you're powering up from power jack or V-in. When you're powering up from the USB, you don't need to regulate, it is just 5 volt. So 5 volt is accessible from this pin. It is quite useful when you plug different sensors which requires 5 volt supply. And there's also 3.3 voltage rail here. That is also useful when you're having different sensors running with 3.3 supply, different I/O devices, but make sure which satisfy the maximum output current capability of the 3.3 rail. So you cannot connect more and more I/O devices because there's a limitation of the output current. So be careful. And we can start from the from this. There are 2 adapters here. This one is for ISP programming. For this chip, there's a USB converter because like the computer and the microcontroller need to have a USB converter. So this chip is Atmega 8 to Atmega 16, which convert whatever the data coming from the USB port to a serial communication, which is understandable for Atmega 328P, because Atmega 328P does not have this USB communication protocol, so it needs some additional help from another external microcontroller, which acts as like a middleman. So whatever the data comes from the USB is converted to understandable data to the microcontroller. From this USB interface, you can program this microcontroller. It has a bootloader inside. And this one is used to program this microcontroller. And there's another ISP interface here. So if you want to program an external microcontroller using this Arduino board, it can this can be used as a program, right? So you can burn the bootloader to another microcontroller using this interface, or you can program different microcontrollers using this Arduino Uno board, which is acting as a program. So that is not covered in this lecture, but make sure this one is for this, and this one is to program external microcontroller using your Arduino board. Right, so the Arduino has many pins. So up to pin number 28. So pin number 0 and 1 is for serial communication, RX and TX, which is also connected to this microcontroller. There are 2 LEDs. So when you're having a when you're programming, you will see these 2 LEDs are blinking, which means there's this communication is running. If it is malfunctioning, you won't see any of these LEDs blinking. And when you power up the board, this power LED will be turned on, so you know like the power is available to the your Arduino Uno board. So basically, pin number 0 and 1 can be used for TX and RX, which is for serial communication, RS-232. So which is quite useful when you're having sensors or devices which is communicating with the Arduino with the RS-232. Pin number 2 up to 13 are digital input and outputs. So whatever this sign is for digital pins, which can also be used as PWM outputs. So pin number 3, 5, 6, as well as 9, 10, and 11 can be used to generate PWM signals. And so you have a ground connection this here, this side, and two ground connection in this way. And there are some other grounds available here as well as in here, right? So ground can be accessed in different points of the board, which is quite useful when you're having different sensors or devices interfacing with Arduino. So other than stick to these 3 pins, you can also use this pin and this pin. And so, like I mentioned, the functionalities in the ATmega328B is here, nothing new. So it is also embedded and displayed here. And this SPI communication pins are these things: clock, MISO, and MOSI, and chip select. And that is mirrored in this port as well. And I2C communication pins are this is 2-wire communication, serial data, data, and clock. These 2 pins are mirrored and mirrored here. Nothing new, like PC5 and PC4 pins are mirrored here. So either you can use this one or this one. So that has been used in our 3 version of the Arduino board. So this is analog reference pin. So if you need to connect an external reference voltage for your analog signals, you can use this one. And other than that, this side is for all analog inputs. There's no analog outputs, only you can use analog inputs for ADC. This is the reset button, as I mentioned. IRRF is the reference voltage for some kind of shield that you're using. This is also generating a 5-volt supply, and this pin is not connected to anywhere, right? And so this reset is disconnected. You don't need auto reset. And there's a LED light for debugging that is connected to pin number 13. So you can write a very similar, very small or very basic test code like a blinker LED. So you don't need to connect external LED, because pin number 13, it is connected to a LED on the board. So you can write a code and see how this LED is blinking, because there's a inbuilt LED connected to pin number 13. So that is useful when you write a simple code for like a LED blinking code and see how the board is working. So this is again the legend and the description of the pins, and you can refer that. And there's a reset button. So reset button is to reset the whole microcontroller and start from beginning. So which is very much similar, like you pull this reset pin to ground also to reset, right? The same thing will happen by pressing this reset button. The reset is quite useful when your code is stuck, or when the microcontroller is not working. You can reset the system and get it working again. That can happen due to different reasons, like due to bad program, or due to some kind of EMI interface with your chip, or any kind of voltage spikes coming from this V-in or this external supplies, or any voltage spikes coming from your analog signals or digital inputs or any communication channel. So that will stuck your code. So then you can reset and get the system working again. So that is all about this ATmega 328P microcontroller embedded to Arduino Uno. So you can refer this one and see how these pins are connected. So when you're working with this board, you need to know these pin descriptions and the purpose of them. to connect the right input-output devices to work with properly. So that's all about this lecture. So I encourage you to read this one again. And there are some other useful videos available on the internet. So we have this Arduino Uno board in our labs. So once you are coming to the university for practicals, we can work with them. If you have Arduino Uno board at your home, you can play with it. You can write a simple test code. So before that, you have to download the Arduino IDE from the internet. So once you download, then you can install in your computer and you can plug into the this board using this cable. And then you can write a small LED blinking code. So there are plenty of videos in the YouTube available for this kind of getting started with the Arduino Uno. So you can give it a try and see how this works. Write like a simple LED blinking program and see how this light is blinking on port number 13. And then you can start more and more advanced programming using Arduino. So that's all to this lecture, and thank you for listening. And so the resources will be available on the LMS.